want to ask, but someone's got to step up. And so I want to finish, and I am recording. I want to do a little bit more with induction. Again, if you see one of these problems, it would be an extra credit. You will see it in Calc 1, so I want everyone to have seen it. And then we're going to move on to Chapter 2, right? So I'll try and get the test review up there soon. We'll start talking about testing next week. I think I did put on the schedule the first test date. So it's plenty of time after we finish Chapter 2. Chapter 2 is a little bit long, a little bit annoying, but really mostly review. Okay, so it's just a lot of material in Chapter 2, and I think I've broken it into several homeworks. So 2.1 itself has like 3 homeworks to it. So, but anyway, let me finish up one or two more problems with induction. So we'll do an easy one, and then maybe one more. If I have the series, right, from I equals 1 to n of a sub n, and it turns out to be the odd numbers, right? So like 1 plus 3 plus 5 plus ... We should now be able to figure out that last term. And since we can figure out the last term, it's going to be easy to find the next term, right? So does anybody have it written down? What is the series for odd numbers? So we could figure it out for sure, right? We could figure it out easily. We could use our a sub 1 plus d times n minus 1. And obviously a sub 1 is 1. And what am I adding every time to get to the next odd? I'm adding 2, right? So 1 plus 2 times n minus 1. So I get 1 plus 2n minus 2. So I get 2n minus 1. How are we doing there? Everybody okay with this? Comfortable with this? You're going to see a problem just like this on your test, right? So I know my last term is 2n minus 1. And obviously I'd be able to get the next term, and that's the secret for induction, okay? But what does this add up to takes a little bit more work, right? What does this particular thing add up to is n squared. And that's kind of unbelievable a little bit, that this thing will add up to n squared. So for example, if I did only one term, right? One term, one of the odd terms, does that give me 1 squared? Yeah, right? 1 equals 1 squared. And if I did 2 terms, 1 plus 3 is 4. Is that 2 squared? Yeah. Yeah, so it seems to be working, right? So we're gonna do our proof by induction, right? So I'm doing a little kind of check. I'm not officially doing it yet. I'm not writing it down formally. I'm just looking and seeing, oh, it seems like it works. Now you could, so now your job is not going to be to come up with this, but you could come up with it, right? You could come up with it. You could say that the sum of 2n minus 1 is the sum of 2n minus the sum of 1. Or I better use I guess, right? Sorry. So that's 2 times n times m plus 1 all over 2 minus n, right? So you can see here, my 2's are going to cancel. And then I'm going to get n squared plus n minus n, and then I get my n squared. So your job is not going to be to come up with what this particular thing is. Your job is going to be to prove it's true using induction, right? But we certainly know how to generate this answer. And when I come up with a problem for you, that's what I'm going to do. I'm going to pick some arithmetic series and see what the results are, and then ask you to prove it by induction, okay? But only for extra credit, right? Unless you're a computer scientist. Computer science majors should be doing this. The computer science majors should do this, okay? So
do we have to?
You don't have to do anything, right? I always say in life, the only thing humans have to do is die. And because I'm such a procrastinator, I'm going to put it off to the very end of my life.
Then I'll put this off.
That's
that was actually kind of funny.
Thank you, Alex. It was meant to be a joke. Morbid, yes, but. So here we go. Proof by induction, right? Let n equal 1. On the left-hand side, we have the sum of I equals 1 to 1 of 2i minus 1 equals 1, right? It's just the sum of the first odd number. On the right-hand side, we have 1 squared, which equals 1. So it works for n equals 1. For me, because I'm curious, I already kind of mentally checked for 1 and 2. I want to even check for 3. What are the first 3 odd integers? 1, 3, and 5, right? So what do 1, 3, and 5 add up to? It's 9. And is that 3 squared? Is that last index squared? And the answer is yes. So kind of informal right now, right? I'd probably like you to write it for 1, 2, and 3, maybe mentally check for 4 and 5. But then what do? We are going to assume it's true for k. Assume the sum is true for k. So I get the sum from I equals 1 to k of 2i minus 1 should equal 1 plus 3 plus 5 plus ... all the way up to 2k minus 1 should be k squared. We're assuming all of that is true. I felt like I'm writing that kind of fast, so let me make sure you're all okay here. K. Alejandra had asked, where is the student solution manual? I have the book solutions for you if you're interested. But then otherwise, of course, the solutions on Math Excel are just kind of prompted as you answer. So Alejandro, send me an email and I can send you book solutions. And I was talking about the calculus course, but I have the solutions for in a PDF form for the textbook if you want those. Now, how are we doing here for speed? Everybody with me?
I'm good, yeah.
Yes.
Nice. So I want to start to think about what my next term is. Because remember, I have to assume this is true for k and show it's true for k plus 1. So I have to be thinking about adding the k plus 1th term. And I have to figure out what that next term is. Look at my last term. The last term was 2k minus 1, but I want k plus 1. So I've got to substitute. So the next term, I've got to put a k plus 1 into k. And this is why it gets tricky every now and then, because I've got to think about k moving to k plus 1. And then I might have to use parentheses. Not that it's difficult, right? So what do I get? 2k plus 2 minus 1. I get 2k plus 1. There's my next term. And that's the secret. So I'm going to be now going, and if you think about it, what did I actually add to my last term here? What number did I add to my last term to get the next number? What?
2.
Exactly. I added 2, and we knew we were doing that anyway, right? We knew we kept adding 2 to the, right, to see what's coming next. But I need it in this abstract form, right? So, so the sum from I equals 1 to k of 2i minus 1 plus that 2k plus 1, right, should now equal 1 plus 3 plus 5 plus dot, 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 the 2k minus 1 plus the 2k plus 1. Remember, I'm adding that last term, and that should equal k squared plus 2k plus 1. Right? So I've added that last term to the 3 parts of my equation. The left-hand part, the middle part, the right-hand part. When I'm adding the same integer to an equality, right, on both sides, I keep equality, right? When I'm adding the same thing, I keep equality. So I assumed it was true for k. I added the next term, so it's still true, and I now want to see what I get, right? You following me? Anybody?
Yeah.
Nice.
Yeah.
Yes?
Yeah.
Nice.
Yes.
So I start with something equal. Yes, I assumed it was true, right? Like if I'm going to say, if I was 10 feet tall, I could dunk a basketball, you'd have to let me be 10 feet tall, and then I could show you, and it would be easy, right? But so in math, we have to start with some assumptions that things are true, that 1 plus 1 is 2, right? And then we can prove other things. So on the left-hand piece now we know that the sum from I equals 1 to k plus 1, right, of 2i minus 1 is equal to what I have on the right-hand side, k squared plus 2k plus 1, right? So now I'm assuming that's true, and I want to see what happens on the right-hand side. And it should be like, oh yeah, of course the whole thing is true now. And so remember what we did. We assumed it was true for k. We added something equal to every part, so it's still true. And the secret is, what's the next term? Find the next term. And now let's see what happens on the right-hand side. Remember, I should be proving that this thing is true not for k, but for k plus 1, right? And guess what I have? Look at this. This is like 8th grade algebra, right? You see that this thing factors? What are the factors of 1 that add to 2?
Yeah.
Yes, this is k squared plus 2k plus 1. That's k plus 1 quantity squared. That's what I wanted. Remember, I wanted to show that it turned out to be n squared, right? Then I assumed it was true for k, so it worked for k squared. And I wanted to show that I would get k plus 1 squared. So done. It's proved. So by induction, we have the sum of I equal 1 to n of the odds 2i minus 1 is always n squared. So when you go do, so what I would say is the next one you should do on your own, and I'm talking to my computer scientist here, is the sum of the indices squared, right? We had sum of I, we proved it for, right? We proved it for the sum of the odds. Now prove it for I squared, right? The next one in our list of 4. And if you want to go crazy, do the next one in the last one in our list of 4. And then certainly you could try a homework problem. And the homework problem would be more looking like this, not one of the ones that we are going to have on our formula sheet. And, if you're a bio major and you're just completely lost, I'm okay with that, right? Just make sure you have those 4 summation pieces down. You're going to use them in calculus. Why do I want some of you to at least know the proofs of them? Because you're going to use them in calculus, and you don't want to just accept. You want to actually know it's true, right? All right, we're going to move on to chapter 2 here. Any questions for me? Any concerns? Any worries?
Nope.
Nice. So we're going to be talking about functions here. So normally this is where most teachers would start when they're teaching pre-cal. But, you know, I tried to scare some of you away. I did get one student to drop. That's really my goal, but, you know, there's lots of reasons to drop. You get a job. You just decide to change your major. You decide you hate math. All good reasons.
I mean, I enjoy algebra.
Yeah, but you're not sure about pre-cal yet.
Well, I took pre-calc and calculus in high school, and it was okay. But I dropped out of AP and just took regular. So
Yeah, AP's pretty fast. It's pretty dense. The Calc 1 that you take next semester is half of Calc AB. So
okay.
Calc 1
What?
and Calc 2 is AB. Calc 2 and Calc 3 is BC. Go ahead, Joseph.
Oh, I got my AP Calc, but I didn't do well on the APs, and that was not a fun class.
Yeah. The test is brutal. The test is pretty brutal.
It really was.
Yeah. You're like, what the hell language is this?
Yeah, like I was
hate
feeling
proof stuff.
confident in the
Yeah.
class. I had to see the whole time the
Yeah.
test came. It's like none of this is
Yeah.
what I learned.
What is this? Yeah, exactly.
I learned
I
none
had
of
a
this.
D, so good for you.
I got by surely by luck.
That's okay. So you're going to get an A in Calc 1 then. Okay?
Shit, I hope.
Get an A in this class, get an A in Calc 1. So we're talking about functions. Let me share a picture of the book here. Let's see if did it close on me. No, it didn't. Good. So I want to share a picture of the book here. You know, and I know reading the book is not that easy with the Math Excel, but I am kind of asking you to read it. And the way you read a math textbook is with paper and pencil or whatever you choose to write with. And as they do examples, you're doing examples, right? And so, and then you ask questions. Robert, they have this weird notation here. I don't even know how to say it, you know? And I'd be like, oh, it's, you know, it's n factorial, right? So the only thing why am I asking you to look at this is because there could be a couple of issues here in 2-1 that should be a review. So if you took Math 50 here, if you took Algebra 2 in high school, you should be able to deal with interval notation. That's probably the one I'm most worried about. So when I start teaching things, if I'm writing things that you don't understand, you got to let me know, okay? And then it could be I suggest some nerd on YouTube for you to watch for interval notation, or maybe you just pick it up, right? Maybe I slow down a little bit and pick it up, and you'll be able to pick it up. So, but it's got to be you communicating with me, okay? Really want you asking for help and making sure that you're getting your money's worth. I'm paying you. I'm your Uber driver, right? So you can see that we should know interval notation. We should be able to solve an inequality. We should be able to plug in numbers to an expression. We should be able to rationalize denominators. So all of these will possibly show up as issues for us if we're a little bit weak in the algebra. So here we go. We're doing 2-1. My goal is to finish 2-1 today. It might be a little fast, so you have to really let me know because I just finished my second cup of coffee, had a couple of Red Bulls. No, but if I start going too fast, slow me down, okay? So lots of things to talk about. We have to talk about if something is a function. We have to be able to plug in to a function. We're going to find the difference quotient. We're going to find the domain, and we're finding sum and differences. This is I think I created 5 homeworks here for this. Let me just take a quick look. mathexcel.com. That's the way I always get in. I guess once you save it, you can save a link and then save your password so you don't have to think about it. So I'm just double checking what I created a couple weeks ago. I don't remember, of course, because why would I remember?
In the passage of time, weeks ago is basically forever.
It is.
So why would anyone be accountable for something they did weeks ago?
I agree. You've got a future as a philosopher, I believe. So 2-1, I created 2 homeworks. The first one is, 3 homeworks. Yeah, homework 4, homework 5, homework 6 is all 2-1. So kind of splitting it up, okay? And then 2-2 is only 1, but 2-3 is another long section, right? So there's 3 homeworks in there. So just be patient. I did that, so I'm trying to create a homework that's at most 10 problems, so that it's not so super annoying. I know it still will be annoying a little bit, but so just take a look at those. I think I should get to all of 2-1 today. If I don't, and you get to a problem in the homework and you don't know what to do, you do the first thing that I would do and curse out the teacher. That's what I would always do. What the hell? What the hell am I paying for? Second thing you do is you look at your notes or look at the textbook, or you can go Google it, but I'm saying don't waste more than 5 minutes on this process. And then certainly you can ask me next class, or maybe I just didn't get to it, right? So it's just that kind of, give and take with any relationship. Try not to be so annoyed with humans. All right, here we go. We're talking about what is a function. And so in terms of a real simple human aspect of it, it's don't tell me, I forget. It is a predictable machine. And my writing gets a little funky at times, just if there's something I'm writing that you can't see. Predictable machine, right? It's like when I go turn my car key every morning, my car should start. It should be predictable. And if that's the case, if every time I turn that car key, the car starts, it's predictable, right? That's what we want to happen, right? If I go put money in a soda machine, right? Even though I'm diabetic, and I hit the button and out comes a Coke. Nice. Put the money in, I hit the button, out comes a Coke. Put the money in, hit the button, out comes a live chicken. All of a sudden, this thing is not working properly. It's not functioning, right? I mean, I'm not horribly upset because you can have the eggs, and on some Sunday you can break the chicken's neck and have a nice chicken dinner, right? But I was thirsty, right? So I need this thing to be what we call well-defined, right? When I put in something into it, I should be able to predict what comes out of it. And so the way I say this in terms of mathematics, I think that's Joseph and Malcolm. You guys just mute while you're listening, okay? I gotcha. I'll do it. Thank you. So the way we say this in function in terms of mathematics, right? So this is life, right? And this is math here. We're talking about for each unique input, there should be one and only one output. So when I say unique input, I'm saying every time I put a 2 in, I get the same result out, right? It doesn't have to be the same result if I put a 3 in, right? I'm saying anytime I put a 2 in, I better get the same thing out. Money in, soda out. Money in, soda out. As soon as I put money in, chicken out, right? No longer a function. So that's the thing I'm really looking for. I'm looking for repeated inputs with different outputs make this thing broken, right? They break the functionality of it, right? So repeated inputs will always have the same output. Think about it in terms of being a computer scientist or biologist doing an experiment, right? So for the biologist, I'm doing an experiment, I should get the same results, right? This is our whole thing, scientific method. I can't prove it's true, but every time I do it, I get the same results, right? So in mathematics, we can actually prove it's true. So we don't have to keep doing the experiment. We can just call this thing a theorem, right? So, but repeated inputs will always have the same output. So looking at function notation, how are we doing so far? This seemed like a repeat on everything, on things you've seen before on LES?
Yeah.
Joseph, thank you. So our notation is y equals f of x, right? So what we used to have, like on our xy axis, is we'd have some point, right? X comma y. But now we can write this point as x comma f of x, right? And then certainly the curve that goes through the point is my function f of x, right? So the curve itself is the whole function. And the height at any one point is an x comma y or an x comma f of x. So we have to be able to talk about the domain of functions, the range of functions, and we have to be able to look at them several ways. So what is the concept of domain, right? It's allowable inputs. If it's a soda machine, if my function is a soda machine, I can put paper clips in there, right? But it's not going to do anything for me, right? It's going to piss someone else off. I can put coins in, I can put dollars in, I can put a credit card in. So allowable domain, right? Allowable inputs is my domain. And you can see the word in, right? So we're talking about inputs. It's inside, right? And it's the independent variable. Outputs, or range is the y values. Oh, these are x values, right? These are x values. And you can see where does the x exist in that f of x is inside, right? So I'm always thinking domain is inside. And so my range, we're talking about y values. We're talking about heights of the function, right? The output is the height, how tall it is up on the graph, and the dependent variable. I can put anything I want into the domain as long as it's allowable, but what comes out is out of my control, right? I'm allowed to put anything I want that's legal in. They can't put paper clips. I mean, I can put paper clips in, but that's going to work into the soda machine. And then what comes out, I have no control of it. It's already predetermined, right? And so there's a couple of ways to find domain. But let's look at some problems here. How are we doing so far? This is all theory, yada, yada, yada. Nice, Michelle. Give me a thumbs up there. So let's look at a couple of problems here. I'm going to my Math Excel. And I want to look at functions and domain and range. That's my first piece for today. So the first type of problem I have here is can I decide if this thing is a function or not? And so I want to look at the domain here. Notice the domain are the x values. So can someone read me those x values there?
4,
4,
negative 7,
5, and 4.
and 4.
Okay, so we already don't like the repeat, right? It's like when you have a grandparent and they keep telling you the same story over and over again, right? It's like, oh, okay, this again, okay, grandpa. And so, but in this case, he changed the story. It wasn't a fish this big. It was no. So in the first situation, I got a 6 out of the machine. And in the last situation, I put in the same 4, but I got a 15 out. So what do we know about this already? Not a function.
It's not a function.
Not a function. Not predictable, right? And so my domain here, I don't need to repeat domain, right? And I usually like to go in order, but so negative 7, 4, 5. I don't need to put the repeated 4 in. I don't think it would mark me wrong. And it won't mark me wrong if I don't put them in order, but I'm just trying to be, trying to think as much like a computer as I can. So what's the range here? What numbers am I getting out?
6, 6, 10, and 15.
6, 6, 10, and 15. Does that repeated 6 break my machine?
No.
No, because all I care about is unique inputs. So I care about a 4 as an input, and I care about a negative 7 as an input. I don't care what comes out, right? It's not in my control. But when I put the same thing in, I had better not get something different, right? Because then it's not predictable. So this particular range is 6, 10, 15. Now, if you're answering something like this, and I'm not going to give you something like this on your test, but you've got to turn in some paperwork, right? The issue with not turning in any work is if you get it wrong, how can I give you any partial credit? And then the other issue is if there's nothing to do, why are you wasting your time? So I'm going to try and not put a problem like this on here. But, you want to think about how you could be possibly writing these things on paper, right? So I'll try and do a little bit better job of that in the next problem, but this one, I'm not going to give you this one, right? It's too easy. I don't like easy problems on the test. Actually, that's not true. Always the first problem on the test is always very easy. It says name, and then there's a blank. It's a fill in the blank question.
Whose name do we put in?
Exactly. So if you're going to copy off of somebody, you're in trouble because I'm only going to grade one test, right? So this is not a function. We already know because of A or C. Is the 10 an issue? No, that's a Y value. Is the 4 an issue? Yes, that's the X value, right? So nice. So we don't need to keep looking at problems like that. So they're a little bit annoying, but they're quick. They should be quick. Is this piece a function of X? Is this particular function a function of X? What does this guy look like?
Looks like a normal equation.
Well, yeah, but more than that, we actually know the shape of it. Yes, it's that parabola, right? It's the parabola. So we've got 4x squared plus 6x plus 9. And if I draw a picture of it, right, and I will ask you to complete the square on this eventually, but I certainly could try and find the vertex. I can use my calculator, but you're going to have to show me some work on your paper. So I'll cheat right now. I'm going to graph this guy. First of all, it's a parabola, and I know it opens up or down. Which one?
Upwards.
Upwards, because the positive, right? That positive leading coefficient of 4 we'll get this thing to, so 4x squared.
Translated to what, 6 over?
Yeah. And I graph that thing, and I see my vertex is over here. Okay, and one of the things we're going to be doing today, this semester, is we're going to be taking this parabola, turning it into vertex form. I'm going to do that right now. It's going to bother some of you. So I'm going to factor out the 4 from the first two terms. And make sure when I distribute back, I see that 4 cancels, right? So I get, what, 3/2 here. So I factor out that leading coefficient. If it's not a 1, I factor it out. If it's a 1, it's easier. This guy used to be B, right? This one is B, right? This is A, this is B, this is C. So this guy here, oops, and that's a 3/2 x, sorry, not a 3/2 plus x. This guy here I call K. And so what I do is I get half of K, which is half of 3/2, which is 3/4, and I square it. I take half of K and I square it. So 3/4 squared, that's 9/16. And I want to add it on the inside and subtract it on the outside. So I've got y equals 4 times x squared plus 3/2 x plus 9/16 plus 9. But this 9/16 is really 9/4, so I'm going to subtract 9/4. Do you see why the 9/16 is really 9/4? Yep. Anybody else? See why the 9/16 I put on the inside there is really 9/4?
Yeah.
Yeah, once I distribute that 4, right? And so this piece is now 4 times x minus half of k, plus half of k, all quantity squared, plus 27/4. And so I can see that my vertex now, the vertex is coming from negative 3/4, comma 27/4. And so it makes sense where I put where it got the vertex, and it opens up. That's all I really care about. Am I in the right quadrant? So that might freak a couple of you out, but I'm okay with that. When I get to this section, which is chapter 3, chapter 2 is functions, chapter 3 is linear functions, quadratic functions, and polynomial functions. Chapter 4, I'm getting ahead of myself, but it's just never ending. So don't freak out too much about that. But you remember that before? It's called completing the square. Have you seen that before?
I have. I don't like it.
Paris has seen it before as well. Anybody else?
I don't think I have seen it.
You haven't seen it before. It's fine. But when I get to that section, I'll teach it a little slower. I mean, this is like the most difficult problem I could give you with completing the square. But I'm trying to show you just that I can now see that vertex is in quadrant 2, right? So anyway, is this a function of x? Well, on the right-hand side, it's clearly the variables are all x, right? F of x is what? 4x squared plus 6x plus 9. But look at the domain. Are there any repeated heights?
No.
Are there repeated... So at any x value, are there repeated heights, right? And so I'm talking about this guy. I'm talking about that vertical line test. For every x I hit, I should hit one and only one height. So it works there. Have it over here. For the one x I hit, how many heights do I hit? One height. So it's a function. It's a function of x. What's the domain?
All real numbers.
All numbers. This thing is as wide as I want, and the x's are, right? I like to say shadows on the floor. Like if something is here, I would cast a shadow on the floor. So as wide as something is what will give me the x values of the domain, right? So our domain here is minus infinity to infinity, or bold R for all real numbers. So you can already see I can get domain from a table. I can get domain from a graph. I should be able to get domain from algebraically too, but in this particular case, there's no algebra to do. Let's just go to their next problem. Is this piece a function of x? Is y squared equals 6 minus x squared a function of x?
No.
Nice. So this is homework 4. I think it's number 5. Is it 5? Homework 4, question 6. So y squared equals 6 minus x squared. This particular piece, if I'm going to graph it on my calculator, I need to solve for y, right? So if I solve for this for y, I get y equals plus or minus the square root of 6 minus x squared, right? And so
that plus or minus you can't have.
The plus or minus is the issue. It's going to give me the top half of a parabola, right? So there's the plus rad square root of 6 minus x squared. And then the negative is the bottom half. So you can see a parabola but turned sideways. And so now we no longer have a function of x, because with a single x value, there are 2 y values. There are 2 heights. Right? If you look at that as f of 0, I get this plus or minus square root of 6. So when I put in 0 one time, I get a positive rad 6. When I put in 0 another time, I get a negative rad 6. How we doing here?
Okay.
Nice. Anybody else? On hell, gave me a thumbs up. Everybody, anyone else okay? Anybody?
Yeah, it's fine.
You're okay? Paris, thumbs up.
Can I see it again? Can I see
yes.
it, sir?
Grace, yes.
Yeah. I want to be clear more.
No problem. So the idea, Melgamu, is if I graph that, right? If I graph that, can I look at the graph and decide whether I've got 2 y values or not, right? At a particular x value. And that's the issue, right? When I have a single x input, I can only have 1 output. If I have more than 1, it's hard to tell which one is the one that's going to work. This particular one is an ellipse. These are really nice to draw in on Desmos, and I would invite you to do that, even though you're not going to use Desmos on a test. But if I go to Desmos, our calculators are kind of dinosaurs. They don't graph things that nicely. What did I have? I'll pull it up even here. Oops, it's over here. It's 3x squared plus y squared equal 1. So 3x squared plus y squared equals 1. So I get an ellipse, right? And so you can clearly see at 0 there are 2 heights, right? So not a function. So when you're doing these things, Desmos, it's nice to graph on Desmos. You can certainly solve, some of them you can solve for y and graph them on your calculator if you're doing that plus minus piece. What's the domain of this function? this number
All
8.
real numbers.
All real numbers. This is number 8 minus 3x plus 2. Homework for number 8. Y equals minus 3x plus 2. So the question kind of becomes, what numbers am I allowed to multiply by 3? Any of them. What numbers can I multiply by negative 3? Any of them. And then for which numbers can I add 2? Any of them. So it's pretty easy to see that any x is allowed to be plugged in here. Any number is allowed to be plugged in here. If I look at the actual function, the graph of the function, I can see the shadow on the floor is the x-axis. If I squash this curve down onto the floor, it hits everywhere on the x-axis, right? So my domain here is minus infinity to infinity, or bold R, right? And I think MathXL is asking for intervals. Yeah, type your answer in interval notation. Nice. What's the deal with dividing? What are my rules with dividing? What am I allowed to do? What am I not allowed to do?
Was not tough.
I can't divide by...
You can't divide by 0.
Right, can't divide by 0. Actually, you're going to learn, as you learn calculus, you'll learn that you can divide by 0. It's just pretty complicated, and the results vary. So, but for now, we've been lying to you, saying, you cannot divide by 0. We didn't say why yet, right? Same thing. We don't want you to smoke pot. We're not going to tell you why. Just listen to me, believe me. So let's look at this particular
Wait, would
function.
divided by 0 just be 0?
No, that's the problem. Sometimes when I divide by 0, I get infinity. Sometimes I get 1. Sometimes I get e. The results vary. And so this it's called an indeterminate form, right?
Okay, I guess we'll learn it later.
Yes. About halfway through Calc 1. Yep.
Okay.
So let's look at this particular function, x minus 10 over x squared, x cubed plus 2x, right? So y equals x minus 10 over x cubed plus 2x. And we want to find the domain here. So far, we can find the domain from a graph. Certainly I could graph this and find the domain. And just be careful when you graph this that you wrap, in the multi-terms in the numerator and the denominator in parentheses. But the real idea is just to look for the bad numbers. And the bad numbers are going to come from when I factor downstairs. So I get an x times an x squared plus 2, right? So it looks like I get x equals 0. So I want to make sure x does not equal 0, because then I'm dividing by 2. I'm sorry, dividing by 0. So my domain in this particular case is minus infinity to 0, union 0 to infinity. And of course, if I looked at that graph, you'd see there's no y values at 0. So we have a couple of things to think about. If you can look at the graph, squash it onto the x-axis, that will tell you your domain. If you're dividing, solve for the downstairs to be 0. And if you're taking a square's root, of course, we don't want square roots of negatives, right? I think that's our next problem here. How are we doing here? We okay?
Can you just explain how you got the domain? Like, I understand everything up to the domain part.
Yes, so whenever I have a rational function, meaning a fraction, I'm going to factor that denominator, simplify, and then make sure I don't get any zeros out of the downstairs. So don't allow a 0. If you allow a 0, it would be trouble.
Okay.
Yeah. And you'll see we'll only have a few rules like this. We're not allowed to divide by 0 at this point. We're not allowed to take even roots of negatives. We can't put we can only put numbers bigger than 0 inside of a log function, right? So we're going to learn that one in chapter 4. So far, linear functions domain is everything. Quadratic functions domain is everything. In fact, polynomials domain is everything. But we're going to kind of get there slowly. Let's look at that next one.
How would you write that on Math Excel?
Yeah, that interval right there. That's what they want. And there's a union symbol in the math palette. When you
Is there any infinity symbol as well?
What is that? Is there any what?
Infinity?
Yes.
Symbol?
Yes. Yep. So the domain, what did I get? So there's my minus, right? So minus and then my infinity, comma 0, union, there's my union symbol, 0, comma to infinity. And enter.
Okay, thank you.
You got it. Good. Square root function. Now I have a square root function. So what's the true about an even root? I can't take an even root of a negative number, right? So let's take a look at this one. So I've got my function f of x equals square root of, I forget already, it's pretty sad. The brain's not quite awake yet. Of 3 over x plus 5. Now I know that I cannot have x equals negative 5, right? I already know that I cannot have x as negative 5 because I'm not allowed to divide by 0 yet. Even when I am allowed to divide by 0, I still can't put x as negative 5 in there. But I also know that the whole fraction cannot be negative, right? So I want to make sure my whole fraction is greater than 0. I'm sorry. I want to make sure my downstairs is not negative, right? Better yet, sorry. The upstairs is never going to be negative, right? So I just have to make sure my downstairs is not negative. So x plus 5 is greater than 0. So what do I get? I get x is greater than 5. And so the negative 5 is not going to be an issue anyway, right? So what's my domain now? It's the numbers from 5 to infinity, and that's it. Oh, sorry, negative 5. And since I have x is greater than negative 5 won't come into play anyway, right? Is that making sense? May have confused a couple of you there, but when I move that 5 to the other side, it becomes negative, right? And it says x must be greater than negative 5, so I can't allow a negative 5, so it's not in my domain. Nice, not too bad, right? Is something a function? Is finding the domain of a function. Finding the range of a function is a little bit more difficult, but we'll get to that in chapter 4, I believe. Algebraically finding the range of a function. Nice, here we go. We got the difficult part now. So I think we've got our first homework done. Here, our first homework is done. So homework 4 you should be able to do now. Homework 5 you should be able to do after this next little lecture here. I will say if you're using Math Excel, if you're using Desmos, it keeps running scripts. So it will, if you leave it open, it will slow your computer down quite a bit. So just understand that. You might need a restart if you fall asleep and wake up in the morning and Desmos was open the whole time. just double checking something here that I have on our Math Excel page. I want to make sure that this is the only other homework here. Homework 4 is functions, domains, and ranges. Homework 5 is function evaluation and arithmetic. I don't know if I need to teach you that one. You know, you have to be able to plug in numbers or add two functions together. I want to go to homework 6, the difference quotient. So I'd like you to do all 3 homeworks, but I don't really think I need to teach you homework 5. And so I'll let you curse me out a little bit in the next couple days or weekend and then see if I have to go back and talk about it. But it's pretty simple. I mean, I'll look at 1 or 2 of them right here. 9 questions in this homework. So I give you a function, and part A says what? Plug in what?
0.
0. So, I mean, I probably the last one, H, part H is the difficult one, plug in X plus H, but I'm going to do that in the difference quotient one anyway. So I think this whole homework you can go right away and do it on your own. Some of the algebra is messy, that's all. Here it says take the 2 functions and add them together. I mean, what do you get when you add them together? You get a quadratic, right? 7x squared plus x minus 5. Right, you with me there? So just add the 2 functions together, subtract the functions, divide the functions, multiply the functions. And then it usually asks you for the domain. So that part might be a little bit trickier, but you just use the same rules I just taught you about finding domain. If you're dividing, make sure you don't divide by 0. If you're taking even roots, don't take an even root of a negative. We stick to square roots only, really. So we have the next homework, which is the difference quotient. And this is such a huge part of calculus that we're really going to be stressing it several times during in our pre-cal class. We're talking about this special function called the difference quotient. So on the curve y equals x squared, if I give you a line through 2 points, that is called a secant line. So a line that cuts through 2 points of a function is called a secant line. And then, of course, we could figure out the slope of a secant line, right? So, for example, let's say this is x1 comma y1, and this is x2 comma y2, right?
Yeah.
So our slope of our secant line is going to be y2 minus y1 over x2 minus x1. But y2 is a function of x, right? And y1 is a function of x. So this really can be written as f of x2 minus f of x1 all over x2 minus x1. And typically what we do is, zooming in on that picture, is we'll call that first point x, and we'll call the second point x plus h. So the distance on this axis, on the x-axis, is the distance h. The 2 x values are h units away from each other. Maybe one x is 0 and one x is 2. Now h is 2. Right? And so if we do that, notice what happens to my function here. What's the new value of x2? So looking from green to blue, what's the new value of x2?
F of x plus h.
X plus h. So that f of x plus h minus an f of x over x plus h minus x, which of course simplifies to f of x plus h minus f of x all over h. And there's finally my difference quotient.
This seems familiar.
Yeah, this is your limits, if you remember from.
Yeah, okay. I remember now.
So the difference quotient, m equals f of x plus h minus f of x all over h. And this is the slope of the secant line. So I could imagine some heads are spinning right now, or you're a little bit going, what the hell are we doing here? So when you first see this, it's kind of difficult, but the idea is you're patient. You write out things very slowly. Don't work in your head. Work on the paper, right? So we want to find the slope of this secant line for my first curve here, y equals x squared. And when the process is a polynomial, it's easy, okay? When my function is a polynomial, it's easy. When my function is linear, it's easier. It's easy. And I want to just break down kind of step by step for the difference quotient for a polynomial, okay? Can I go to a next page here? Is anybody still writing?
You can go on the next page.
Nice. Anybody need another second here before I go on to the next page? 9 minutes left of class. Okay, so here we go. I'm kind of giving you a step-by-step for a difference quotient with a polynomial, right? So the first thing I want to do is I want to find f of x plus h. And then I'm going to find the difference. And that is f of x plus h minus f of x. So I'm subtracting off the original function. Then I'm going to find the quotient. Which is x plus h minus f of x all over h. And I want to factor and simplify. Now, you don't have to do it this way, okay? But I'm saying if you're confused, it's easier to do it this way. Now, we haven't done a problem yet, so it's hard to say whether you're confused or not. But I think when I'm using polynomials, this is the easiest way to go. And typically, I could have a polynomial of degree 0, a polynomial of degree 1, a polynomial of degree 2. I don't really see me ever giving you a polynomial of degree 3 or higher for the difference quotient, okay? So let's start with our function that we had, f of x equals x squared, right? So if f of x equals x squared, then find the difference quotient. So I start with step 1, find f of x plus h. What's really important is that I'm taking my function and replacing the x with empty parens. So notice what's in here is empty parens, but my original function is x squared. So replace with empty parentheses. Replace all x's with empty parentheses. And then plug in. So I should plug in x plus h. And I probably want to simplify that. Right? That's x plus h quantity squared. So, sorry, so that's x plus h times itself. And then I'm thinking of my favorite four-letter F word. No, it's not FOIL, but that's fine. That's what I'm going to do. X squared plus an hx plus another hx plus an h squared. And I've got x squared plus 2hx's plus an h squared. And I want to simplify like that every time. So plug in with empty parens, plug in the x plus h, simplify. Take your time. You will make mistakes. Try not to. How are we doing here? Is everybody with me?
Yep.
Yes, Angel, correct. This is going to lead us to our derivative, which is first chapter is limits in calculus and then derivatives. So I want to find my difference now, and then watch how I do that. I take f of x plus h and I subtract off f of x in a way that is very organized. I'm going to replace f of x lower, but then make sure I negate everything. So notice in black I have the f of x plus h that I simplified. And then underneath it I have f of x negated. So I'm doing f of x plus h minus f of x. And guess what? It's really easy.
Just 2hx plus h squared.
Yes, so the terms without h in them will always go away. This is a key. The terms without factors of h must go away. If they don't, you made a mistake somewhere. If you don't lose all of your terms with no factor of h, you made a mistake somewhere. So what do I get here? I get 2hx plus h squared. Notice that everything's got a factor of h in it, right? And if it doesn't, there's a mistake. Because what am I going to do now? I'm going to make this into a quotient by dividing by h. So I do f of x plus h minus f of x all over h. I get 2hx plus h squared all over h. And then I want to factor. And simplify. And I get my difference quotient of 2x plus h. I like to call it the dq. This will give me my slope of a secant line at any value of x and any value of h. The difference quotient gives me a slope of a secant line at any value of x and any value of h.
So, are we able to just do the quick version of that?
Yes, in Calc 1 after Chapter 3.
So we should do it that way in this class.
Yes. And I know it's going to be painful for you, but I think you could use a little pain.
Yeah, fair enough.
Nice. So difference quotient gives me the slope at any x and any h. So for example, let's see if it works. We've got our quadratic. Let's say at 0, 0, and 2, 4. So 2, 4, right? And then of course, if we get our difference, our secant line there, my slope is 4 minus 0 over 2 minus 0. That's 4 over 2. That's 2. So definitely makes sense that that line would give me a positive slope. And let's check the slope with the dq now, with the difference quotient. I can use either x I want. I can use this as my x, or I can use this as my x. But pretty clearly, the h is 2, or negative 2, depending on which way I use. I'm going to let x be 0 and h be 2. And I get, what, 2 times 0 plus 2. And that, of course, is 2, and it gives me the same slope as the slope formula. I'm out of time. So I think homework 4 and homework 5 is sufficient before Friday. So let me keep teaching the difference quotient on Friday. So don't jump to homework 6 yet.
So just homework 4 and 5.
Homework 4 and 5. Yep, I didn't quite do as much of the difference quotient as I want to. So let me give you less work. All right. Have a great day, everybody. Alex.
Sounds good to me.
Yes, I know, right? Alex, stick around for me, okay? Anybody needs me, let me know.
Yep.
It's just so much easier if we could do it quicker.
Yes, but you are somebody who has knowledge of the universe, and the rest of us,
knowledge.
the rest of us do not yet.
Oh, tragic.
Yes.
All right, have a good one.
All right, see you Friday.
Thank you.
Thank you.
You got it.
Okay.
All right, let me make you a co-host and let me see what you're doing, okay? Give me 1 second here. All right, you should be able to share your screen with me, and then let's get into.
Wait. I think it's this one.
All right, let me look.
Did that work?
Wait a minute. Yes. So your course, so go to Math Excel. You're gonna have to copy that course ID and the temp access code later, so be able to go back there.
I know that.
Yep. Good. Going as. Did you register already?
Yeah. I think. I had a Pearson account before. At least that's what it told me.
That's fine. You can still use that one. That's fine. You can use that one.
Yeah. Well.
Yeah. Agree to terms of use. Even though they're saying that they're going to own our first dog or whatever.
Yeah. I've read it before.
Nice. Enroll in a new course. And there you go.
And then
you can switch to a single box there. So course ID. Nice. And go back to that and then switch to a single box. See where it says right underneath you there? Switch to a single box. There you go. Now you can paste in there. There you go. Yep. Enroll.
Okay.
You're now enrolled.
And then
now homework and tests.
Have to...
No, it looks like you don't. Homework and tests. There it is. You're all set.
Huh? Thank you.
You got it. See you Friday, okay?
Yeah. So.
Go ahead. Say again.
Later.
All right. Nice.
Thank you.
You got it.